Hello friends, good morning, good evening, good night, good afternoon, whatever the case may be. In today's video, we'll solve one more question, and in this question, we'll learn about the dummy variable and how to use the dummy variable in solving this type of questions, and then we'll find out the unrestricted restricted regression, and then we'll use f-test. So let's come back to the question here. So this is a question of 33 marks and I have taken only 15 marks. Okay, so one 6-mark question and another 9-mark question. These two will find around 15 marks. So in this question, it's about one economic investigation into the hourly wages of male and female employees, and we are going to compare the determinants of wage rates for male and female, and we are having the sample data that is about 526. The sample data is 526 paid employees, and out of which 252 are females and 274 are males. Okay, and they are having the variables they have defined this way. The W is the hourly wage rate measured in dollars per hour. Then S is the formal education completed in years and study years. Age, that is age in years. T for firm tenure of employees, that is employee in the firm, how many years they are in the firm. Then F equal to 1 if the employee is female and 0 if the employee is male. Okay, and they have given us the model. So remember, these are type of questions. This is the original model they have proposed, and they have given us beta 1 plus beta 2s plus beta 3a beta 4a square beta 5t beta 6 interactive term. So these are known as interactive term. So s times t. So the farm tenure of employees in years, and how much years of study, formal education he has completed in years. Okay, so both these values, and beta 8 you can see beta 7 f. So a female, and a female, how much female employee, how much years she has studied. Beta 8 coefficient is showing that, and beta 9, that is someone is female employee, and his age, and then as age increases, this beta 10 is showing as an age increases for a female, and beta 11 is the interactive term between female and the firm tenure of that employee. Okay, and beta 12 is taking into account the female employee who has studied some years, and the tenure of the employee. Okay, and U is the normal error term, and this is the second part of this. So where the Greek letters denote and U is an error term, first of all you have to understand, you have to read and understand the question, okay, properly, and it's assumed that all the classic assumptions of the multiple regression model hold, including homoscedasticity. Okay, and then they have estimated, okay, the following estimated, and where the standard errors are of each estimate is written in the parentheses. Okay, right now we are not dealing with any, we don't have to do anything with the standard of error, because this question is not about is not going to use these things. Okay, so let's come back to our question here. So this is 6-mark question, and this is 9-mark question. So let's understand what they are asking to do. So use the estimation result, that means this one, okay, to compute the OLS estimates of the slope coefficients of the regressors S, A and T. Okay, that that means the study and age and t. Okay, so there are three slope coefficient. We have to find the estimates of three slope coefficients. Okay, and then repeat the exercise when only 252 observations corresponding to female employees are used. So first we have to derive it with respect to male, then next we have to derive it with respect to female. Okay, remember only three. I have written more than three, but three we have to keep in mind, that is study in years, age and tenure. Okay, so let's I have already solved these questions to save your time. Okay, so I have copied the equation number 5, that the original one, and this is the estimated one. Okay, so see, I have written them here. So log of wages. So I just wrote this equation 5 entirely, then I'm putting the value. Okay, and this equation estimated one, the sixth one. Okay, so this is sixth one. Now we are going to look for the values of male. Okay, male employees. So when it is about male employees, how we are going to look for it? We are going to find the values. This is beta 1. Okay, wherever male is wherever female is not there, so that is considered here for the male. Okay, so here we can say beta 1, beta 2, beta 3, beta 4, beta 5, beta 6, till beta 6 beta. Okay, till this much we can consider this as the male. Okay, but after that you can see that we are having female here, if. Okay, so if male is coming, we have taken 0, and for female it is 1. Okay, so here if you put the 0, then it is automatically becoming 0. Here also the similar case, anywhere for male, that these values will turn 0, so we are not going to touch that. Our our work will be done with this 6 coefficient till the beta 6 cap. Okay, so this is for males, and for females what you are going to do, it will be, look at it here, we'll be taking into account beta 1, beta 2, beta 3, beta 4, beta 5, beta 6. Okay, along with that, from here beta 7 cap, here what is happening here, this is becoming 1, right? If it becoming 1, that means this value will be there. Similarly here, if it is coming like this, then you are getting 0.01684 s, because f is turning into 1. The value of female is 1 when it is female. So this is 0.01684. Similarly here it will become 0.03847, right? Likewise. So here you might ask why I have just added these values, right? So see, this 0.05937 is nothing but your beta 2 cap here, beta 2 cap. Then when you are taking into the value of beta 8 here, this one beta 8 here, it is turning 1, right? So that means it is, you are only keeping 0.01684 s. So here this is and this is this they are multiplied, so I'm just putting them together and I'm multiplying them by s. Similarly for beta 3 and beta 3 cap and beta 9 cap. Okay, so this is for a and this is for beta 9 cap. Okay, so that means 0.03847 a and here 0.07980 a. That's what I have just used the signs that they have in front of them, and likewise I did. Okay, so they're asking us about s, a and t, right? So if they're asking about the s, a and t, then the relevant relevant coefficients will be this one, right, for s, and this one for a. Okay, and for t will be beta 5 and beta 11. Okay, so here these three actually should be the answer, because they're asking for the s, that is study years, tenure and age. Okay, beta 2 cap plus beta 8 cap, this one, beta 3 cap plus beta 9 cap, this one, then beta 5 cap plus beta 11 cap. Okay, so these are our coefficients, these three, as per the question. But if you want to add them up and just to show when it is how different it is from the males, then you can use all these values. Okay, where you will be using this beta 1 cap plus beta 7 cap and beta 4 cap plus beta 10 cap. Here this is solved. Okay, so question 6 is done. Next let's move to question number 9. So in the question number 9, this is little bit tricky. So it is asking that write the restriction over parameters in equation 5 that the marginal effects of S over ln W and T over log of W are equal for male and female employees. Okay, then you have to provide an expression of equation 5 imposing these two restrictions. The restricted OLS estimation provides RSS equal to 80.8747. Okay, so we'll have to use this information, and along with the information that is provided in the problem formulation, that is in the question number 1, the first question itself, we have to calculate the test statistics. Till now they are not disclosing you the what is the test statistics. You have to find the test statistics. Okay, and then you are going to establish a decision rule using a significance level of 5%. That means first you identify what kind of test you are going to use, then you have the significance level of 5%, and then you have to go conclude. Okay, fine. So now I'm using the equation 5, and they are asking us about the marginal effect of S, that is study years, over the value of log W, and similarly of tenure over log of W of for male and female employees. So you are basically going to find out 4 marginal effects, for male 2, for female 2. So for male we have to look for the marginal effects of S over log of W and marginal effects of T over log of W. Similarly for female employees. So you are going to basically 4 equations. Okay, let's see how it's done. So this is the equation 5, and from here you can the marginal effect, that is we are going to take the partial effect of this one, partial effect of ln W log and 2 S. Okay, then we are going to do it. First you have to find out the marginal effect with respect to study years, then with respect to the tenure in the form. Okay, so here this one, so you will finding it will be beta 2 for male. I'm looking for the male first one, then you are going to find out this one. Okay, rest of it will not be applicable. So you got your beta 2 plus beta 60. Okay, similarly for with respect to for female, with respect to female, what you are going to get, that you will get beta 2s. Okay, then beta 8, because s is here, beta 8, then yes, beta 6 is also there, but here you will be having beta 60. Okay, beta 60, and from here beta 12. So here you are going to have beta 12, okay, t, beta 12 t, and this f will become 1, and you're taking partial derivative with respect to s, so it will become beta 12 t, and putting them together, beta 2 plus beta 8 plus beta 6 plus beta 12 multiplied by t. Okay, and you can see beta 2 and beta 6 come on to both, so difference only beta 8 and beta 12, and you can say that 100 times beta 2 plus beta 60, that percentage is the expected percentage change in wage when s changes in 1 unit, everything else remaining fixed. Okay, similarly marginal effects of t, I think you can, this is easy, we'll just follow the process that we did before. So we found this with partial derivative with respect to t, and we found beta 5 plus beta 6 s. Okay, similarly with respect to t, and we found beta 5, this is for female, this is for male. Okay, so beta 5 plus beta 11 plus beta 6 plus beta 12 all multiplied by s. Okay, so here you can say that 100 times beta 5 plus beta 6 as percentage the expected percentage change in w when t units t changes by 1 unit, everything else remaining the constant. Okay, so now the question is, let's come back to second part, that imposing these restrictions we are going to provide an expression. Okay, we are going to test it. Okay, so first, what is the why we are going for the test, and what are we going to look for? The first thing is, when we are telling that they are equal for male and female employees, that means it is telling that partial derivative or marginal effect with respect to male and study years, and partial effects of study years for female must be equal, and partial effect of male with respect to tenure in farm should be equal to the partial effect of tenure on females. So that means they are telling these four equations. So first, these two must be equal and these two must be equal. So you can see if these will be equal, these two will be equal, that means the case should be that beta 12 and beta 8 must be 0. Okay, beta 12 beta 8 should be equal to 0, then only these two will be equal. And similarly at this case you can say that beta 11 and beta 12 should be 0, then only these two will be equal, right, these two equations. So that means our hypothesis, our hypothesis will be done in that way. Okay, so our hypothesis is, sorry, so our hypothesis will be that beta 8 equal to beta 12 equal to beta 11 must be 0. That is our null hypothesis. And our alternative hypothesis will be that at least one of them is not equal to 0. At least one of them is not equal to 0. Okay, so this is our null hypothesis and alternative hypothesis. Now you can see that this is about multiple coefficients. Okay, so when this is we deal with this such kind of things, actually basically talking about f test. Okay, so they have already told you that you are going to impose the restrictions. So we'll be having one restricted regression and one unrestricted regression. So this one is our unrestricted regression. Okay, and we'll use the value of this and this. So remember, this unrestricted one is the normal, and I have used this as normal regression, and this I have done this restricted one. So in this restricted model, what you are going to do is you will be restricting f beta 8, beta 11 and beta 12. Okay, so our equation will be beta 1 beta 2s beta 3a beta 4a square plus beta 5t beta 6 t and this and you are going to use the values of f statistics. So here this is restricted version. Restricted means the RSS you are going to use is this one. Okay, and the RSS from normal equation, no, the normal one. So the normal here. Okay, so you are going to use this value for the normal one, 80.57. Okay, so 80.8747, this is from the restricted one, and that is RSS from the normal equation, that is 80.57. And here n minus k minus 1 by q. So this is n is number of observations, k is the number of independent variables here, that is 11 and 1. Okay, I have just this is same, this formula is same as this one. Okay, so don't get confused. I've just turned it around and you get the value, that is 0.648. So now you can see that numerator degrees of freedom with 3, that is the number of restriction, and the observations 5 to 6. Okay, so that critical value is 2.60, that is greater than this one. Okay, so when our f statistic, that is computed, 1 is less than our critical value, that means we cannot reject the null hypothesis. So that is why we now there is no evidence against null hypothesis, so we are failed to reject the null hypothesis that the marginal effect is equal for males and females at 5% significance level. Okay, so you can just use the F distribution table to find out the value of 2.60. If you need any video on F distribution, then just let us know in the comments. Okay, so I hope this video has been useful to you. Please like and subscribe and comment and encourage us. Okay, thank you very much.